Page 243, we're going to be doing some reviewing on lessons 4.1 through 4.4. So we're going to look at some vocabulary stuff here first. So the first problem, a term that contains only a number is a blank. If it only has a number, that is called a constant. Examples of constant, we could have 5, we could have -2, we could have -1/3. Anything that just has a number and no variable is called a constant. Number 2, the number part of a term that contains a variable is a what? So the number part, that's called the coefficient. In other words, it's what the variable is being multiplied by is called the coefficient. So if we had 4x, 4 would be our coefficient. Number 3, a variable is a letter that represents an unknown value. If something varies, it changes. And so variables, we've got some examples. We could have x or y. So if you look at lesson 4.1, we're talking about writing and evaluating algebraic expressions. They give you a little bit of an idea off to the side here. You can look at that example. Total cost to pick 5 pounds of strawberries. So this one was based off of cost per pound, and then we were being charged $2 for the basket. So they had P is pounds of strawberries. So they came up with this expression, $1.75 times however many pounds of strawberries plus the $2 for the basket. Then for 5 pounds, assuming we can fit that into one basket, we could take $1.75 times 5 is $8.75 plus $2 for the basket would be $10.75. So if you look at the practice, number 1, Hattie makes and sells knit scarves. Next week, she will pay a $25 fee for the use of a booth at a craft fair. She will charge $12 for each scarf she sells. Write an expression to determine Hattie's profit for selling S scarves after paying the fee for the use of the booth. So what we want to think about for our profit is our income minus expenses. So in other words, how much money we're bringing in minus the things we had to pay for. So she's charging $12 for each scarf. So we'll say 12S minus the $25 that she had to pay for the booth. They're not taking into consideration here, we would have a fee for the materials. There would be an expense for the materials for making the scarves, but they didn't tell us anything about that, so we don't have anything to base that off of. So this could just be our expression for her profit. And we don't know how many scarves she sold, so this would just be our answer for this problem. If you look at number 2, the cost to buy P pounds of potatoes at 32 cents per pound. And N pounds of onions at 48 cents per pound can be determined by using the expression 32/100ths P plus 48/100ths N. So the question is, how much will it cost to buy 4.5 pounds of potatoes and 2.5 pounds of onions? So we're just going to be substituting into this expression. So 4.5 pounds of potatoes and 2.5 pounds of onions. Once we substitute into this, order of operations, we're going to be doing multiplication before we add. So if we multiply these first two numbers, that would end up being 1 44/100. If you multiply the last numbers, that would be 1 20/100. And then if you add those together, that would be $2.64. So $2.64 total. Lessons 2 and 3, they combine together here. This is on generating equivalent expressions and simplifying expressions. So over on the side here, they talked about simplifying expressions. Basically what we're doing is we're looking for like terms that we can combine together. So on the example, the book used the commutative property. Remember, commutative changed the order. They just rearranged these numbers so that they got like terms next to each other. Just makes it easier to combine them maybe. So 1/3 n plus 2n would be 2 1/3 n. With the constants, you can add the opposite on these if you want. This is like -7 plus -4/3, or -7 plus -1 1/3. And so that would be -8 1/3. Other option would be to get a common denominator, which would be 3. So you'd have -21/3 plus -4/3, which would be -25/3. So either way would be fine on that. And if instead, if you had plus -8 1/3 or plus -25/3, that would be okay as well. So let's look at the problems here. They want us to simplify these. So number 1, we're trying to look for like terms. So I see this has an M, and then this has an M as well. You need to just make sure when you're doing these problems, the sign that's to the left of that term goes with that term. So this is like -3/8 M, or if you want to add the opposite to help you see that better, that's fine, but we've got to see that as a -3/8 M, not just 3/8 M. So these, if you want to change the order and get those next to each other, you can. Otherwise, just as they are, you can go ahead and try and combine those. So 5/8 plus -3/8 would be 2/8 M. And then with the constants, we've got a 9 minus 15. Again, if you want to add the opposite here, you can. So this is like 9 plus -15. Those are different signs, so they're working against each other, and we have more negatives. So you could say they're -6, or you could say plus -6. One final thing we can do is the fraction can be reduced. So 2/8 we can reduce to 1/4. So 1/4 M minus 6, or 1/4 M plus -6. Either one of those would be acceptable for that answer. Number 2, we've got, this is a W here, W here. Combine those together would be -2W. And then we've got some Z's we can combine. So -4Z plus 9Z would be 5Z. And then we've got 2 minus 7. If you want to add the opposite, you can. 2 plus -7, that'd be -5, or plus -5 if you want. So you could have that, or you could have -2W plus 5Z plus -5. If you look at number 3, we've got actually 3 D terms that can be combined here. So -2 plus -4 would be -6D plus 3D. We have more negatives by 3, so that would be -3D. So you could have -6 minus 3D, or -6 plus -3D. Lesson 4.4 talks about expanding expressions and simplifying expressions. This has to do with using the distributive property. So if we look at number 1, it says expand this expression. So we're going to distribute here. So we're going to do 3.5 times negative 3n plus 3.5 times 4. So if you multiply this, work that out, that'd be negative 10.5n. And then 3.5 times 4 would be 14. You could put 14.0 if you want, but this would be sufficient. Those are not like terms, so do not try to combine those together. Only like terms can be combined. And then if we look at number 2, to simplify this expression, you have an option on this one if you want. You can look inside the parentheses and see if you have any like terms to combine. So you could actually combine the negative 8 and the negative 3 together, which would be negative 11. The advantage there is that you have less things you have to distribute to. So then we're multiplying negative 3/5 by both of these. So negative times negative would be a positive. This would be 33/5. And then the second one, if you want to do some reducing here, you can. That would be negative 1/3 x. 33/5 is an improper fraction. If you divide that out, that would be 6 3/5 if you want to do that. It's not a real life problem here that I'm aware of, so if you wanted to otherwise keep it as 33/5 since that's reduced, that would probably be okay as well. If you didn't combine those together first, that would be distributing to all 3 of these. And again, you should end up with the same answer in the end. So this would be 24/5. Again, with the variable stuff, you can reduce, which again would be our negative 1/3 x. That should be a 3, sorry. And then negative times negative would be a positive 9/5. And then it's just that at that point we have like terms we can combine. That'd be 33/5 or 6 3/5. Okay, so you do have an option on that as far as combining like terms ahead of time or distributing and then combining like terms. One thing they didn't do much of in this review questions in your book is talking about which expressions are equivalent to something. And to do that, you would want to try to simplify. So for this problem, they want to see which ones are equivalent to negative 4/3 p minus 2/5. This first problem, or this first answer choice, basically they've just got these things flip-flopped, negative 2/5 minus 4/3 p. On the original problem, if you want to add the opposite there, you can. If you want to add the opposite on this one as well, and then maybe you can see better that those are actually equivalent to each other. The second answer choice, they've got 2/5 minus 4/3 p. The problem is that this is a positive 2/5. We need it to be negative, so that doesn't work. A third choice here, we actually now have like terms that we can combine. So negative 1p minus 1/3 p. If we were going to combine those together, we could get a common denominator, and then that would end up being negative 4/3 p minus 2/5. So that would actually be the same as well. If you add the opposite, you can see that's the identical thing there. This next example is basically by adding the opposite, that would be equivalent. And then if we look at this last option here, we've got constants that we can combine. So if we get common denominator, negative 1 is equivalent to negative 5/5, plus 3/5 would be negative 2/5. So we've got negative 2/5 plus negative 4/3 p, and again, that's really just the same thing as what we had here, only the orders changed, so those would be equivalent as well. So just make sure you go through and practice some problems similar to this, also on the distributing section as well, making sure that you can simplify things and then tell whether they're equivalent or not. One other thing we can look at with these sections, if you go back to page 219, there's a mid-topic checkpoint. So the mid-topic checkpoint, number 1, if you write an expression to represent the following situation, how can you determine which is the constant and which is the coefficient of the variable? So the zoo charges the Garcia family an admission fee of $5 per person and a one-time fee of $3 to rent a wagon for their young children. So what we have to think about is what is kind of a set amount and what is going to change or vary. So notice this, it says a one-time fee of $3 to rent the wagon. So that's going to be the constant. And then admission fee of $5 per person, that's going to be the variable because that's going to change based off of how many people that there are. Okay, and we should write sentences out. I'm just kind of doing a shorthand here. Number 2, an online photo service charges $20 to make a photo book with 16 pages. Each extra page costs $1.75. The cost to ship it is $5. So write an expression to determine the total cost to make and ship a photo book with X extra pages. All right, so it's up to you how you want to do this. One thing you could do is say, well, there's $20 and there's $5 for sure. So you could go ahead and just combine those together and say that's going to be $25, and then plus this fee based off of how many extra pages. That would be $1.75. We've got X extra pages, so $1.75 times X. So this could be our expression. Those are not like terms, so we can just leave it like that. Number 3, they want an equivalent expression to that by combining like terms. Notice the addition sign in between with the parentheses here. So this is not distributing. So really they didn't even need the parentheses on this problem. We're just combining like terms. So 2a plus 8a would be 10a plus 5b. Number 4, we want an expression equivalent to that. Based off of their answer choices A, B, C, D, we're thinking only one of these is going to work. But sometimes there's multiple options, so just be careful with that. So 3y plus negative 7y we could combine, which would be negative 4y. And then if you want to add the opposite here, you can. This is negative 8 plus 9. negative 8 plus 9. Those are working against each other, so if you subtract, we've got a difference of 1, and we have one more positive. So negative 4y plus 1, and that would match up with answer choice B. Number 5, Ray wants to buy a hat that costs $10 and some shirts that cost $12 each. Sales tax rate is 7.5%. So they give us an expression to determine the amount of sales tax Ray will pay. Expand the expression. So expand means we're going to distribute. We're going to distribute these in. So we're multiplying 65 thousandths by both of these things. Multiplying by 10 is just going to move our decimal over one spot, so that would be 65 hundredths. And this other one, if you go and work that out, should come up as 78 hundredths S. Number 6, they want us to factor this expression. So factoring, we are trying to find what these have in common. That's actually goes with lesson 5, and so I guess we'll just save that and not worry about that one at this point. We'll get to that next. So this gives you an idea of how to look at some things in lessons 4.1 through 4.4. Have a good day.